Hello everyone. In this lesson, we will talk about knowledge of Chapter 4 of Low-Frequency Electronic Circuits, Amplifier Basics. As can be seen from the previous discussion, three basic configurations of amplifier performance each has different characteristics. The common base configuration has the smallest input resistance and the maximum output resistance. There is voltage gain but no current gain. Its current gain is very close to 1 and a low short circuit condition. And the common collector configuration is opposite to it. It has the largest input resistance, while the output resistance is the smallest. It has a large current gain but no voltage gain. Its value is less than 1, very close to 1. But co-amplifier, its input resistance and output resistance is between the above two amplifiers. Then it has current gain. There is also voltage gain. Different performance characteristics of three basic configuration amplifiers determines their different application in the circuit. In the terms of input resistance and output resistance, common base amplifier is very close to the ideal current amplifier because its input resistance is small. It can get more current from the input. Large output resistance can effectively output the amplifier current to the load, but its current gain is less than 1. So, the common base amplifier is also called a current junction, common collector amplifier. Its input resistance is large. It is very conducive to voltage in the voltage signal source, load onto amplifier. Low output resistance can effectively amplify the amplified voltage signal output to the load. However, its voltage gain is very close and less than 1. So, we also call the common conductor pole amplifier a voltage follower. The cogeneration amplifier has a larger current gain. There is also a larger voltage gain, but its input resistance and output resistance is less ideal than the other two amplifiers. The first idea to improve the amplifier is a combined approach. It will make which have voltage gain and current gain common emitter configuration amplifier as the main amplifier, combined with common collector configuration and common base configuration to make up a suitable combination amplifier. The picture shows a common emitter amplifier T1, combined amplifier with common base configuration amplifier T2. Use the input and output resistance with common base configuration to change the input and output resistance of the amplifier. As you can see from the picture, common base circuit T2 will make the output current of T1 connect to the load resistance RL. Its voltage gain is equivalent to the load of RL's first level cogeneration circuit. In the circuit, if RC is large enough, then the output resistance of the entire circuit will increase. If RB is big enough, the circuit at this time can be equivalent to RB equivalent to an open circuit, because RB and RBE are connected in parallel. If RB is large enough, the equivalent resistance at this time is equal to RBE. IC is large enough. At this time, RL is equivalent to RL. Let's look at another combination amplifier. The figure shows a common collector configuration and a combined amplifier combined with common emitter configuration. T1 tube is a common collector configuration electrode. The electrode's AC path is equivalent to ground. T2 tube is a common emitter configuration. Analysis of its communication channel. We can know that for AC signals, C1 short circuit of emitter of T2 tube is grounded. This common collector configuration and common configuration. The combined amplifier is also called Darlington circuit. Configure T1 with common set. Send the input voltage to the common generation amplifier with little attenuation. T2's input So the voltage gain of this combination amplifier equivalent to the gain of the first level cogeneration amplifier, but its input resistance is due to the attacked circuit and greatly improved. It can be seen that the use of T1 tubes has effectively increased input resistance of the entire circuit. In addition, there is a co-connection combination amplifier. As shown in the picture, configure common collector and a common collector, two amplifiers combined to constitute this combination amplifier. Let us analyze its voltage gain. Let's first calculate, at this time, the input resistance of amplifier Ri. The input resistance Ri at this time is equal to RBE plus 1 plus beta Ri2, where Ri2 is the equivalent resistance of T2 tube. Based on previous study, we know the input resistance of the common collector configuration is equal to the resistance Re. So, we can write the input resistance at this time is equal to RBE plus 1 plus beta Re. Since the two tubes have the same parameters, so 1 plus beta Re equals to RBE2. It is equal to RBE1. We can write it in the form of RBE. So, the input current I is equal to the input voltage V divided by twice RBE. Let's look at the output voltage. Output voltage expression can be written as the negative output current multiplied by the load resistance RL. At this time, the output current LO is equal to the two-stage amplifier. Current after current change factor is equal to alpha times I multiplied by 1 plus beta. The output current LO is equal to input current II, the current amplified by two-stage amplifier. First II go through the T1 tube. The current will equal to 1 plus beta II after passing through the T2 tube. Its gain increased by an alpha. So it can be concluded that the output voltage at this time is equal to II times 1 plus beta and then times alpha. This is the final current multiplied by the load resistance RL. Compare the output voltage with input voltage to get the final voltage gains. As can be seen that the final voltage gain is equal to 1 out of 2. Transconductance multiplied by negative resistance RL. In other words, this combination amplifier, its voltage gain is equal to level 1, which is half of the gain of the cogeneration amplifier. But it has the effect of magnifying in the same direction. That is, the polarities of the output voltage and input voltage are the same. Okay, this is the end of this class. Thank you.